we're going to look at one more problem that is going to help us look at how the sample size relates to the accuracy. So suppose the LDL cholesterol level of all men aged 20 to 34 follows a normal distribution with a mean mu equal to 115 milligrams per deciliter and a standard deviation of sigma equal to 25 milligrams per deciliter. So we're going to look at two different sample sizes and two different sampling distributions. One is based on a sample size of 100, and the other is based on a sample size of 1,000. So we're not going to look at the population distribution on this one. And then we're going to compare the results from these two sampling distributions. So I'd love for you to pause the video, find those sampling distributions, and use Rossmann chance to get some probabilities. All right, so hopefully you gave those a try. Let's go through them together. So the first one says choose a simple random sample of 100 men from this population. So our original population was normal, so our sampling distribution will also be normal. Our mean stays the same at 115, and then our standard deviation will take the 25 and divide that by the square root of 100. So our sampling distribution will be normal with the mean of 115 and a standard deviation of 2.5. So let's put those numbers into the app and scale to fit. And then we're interested in the probability that the average for these 100 men, that they're going to have an LDL cholesterol on average between 112 and 118. So to do one that has two numbers, we have to click both of these check boxes. We'll put a 112 in and a 118. And then we're looking for the probability the average is between those two numbers. So that'll be 0.7699 or almost 77%. And then the same thing, we're going to choose a simple random sample, but now with 1,000 men. So again, our sampling distribution is still normal because the original was normal. We still have a mean of 115, but now for the standard deviation, we'll take that 25 and divide by the square root of 1,000. So it gives me a sampling distribution that is normal with a mean of 115 and a standard deviation of 0.79. So the only thing I need to change here is just the standard deviation. So I'll put that in and scale to fit. And now the probability that the average for these 1,000 men, their LDL is between 112 and 118, is going to be 0.9999. So virtually 100% of the time, if we take 1,000 men, their average is going to sit right there between 112 and 118. So what this is illustrating for us is that the larger the sample size is, generally the more accurate our results are going to be.